have to do it blindfold, so that's why. Okay, let me explain this to you. So what happens is after Calculus 1 is you do derivatives, and then you learn integration, and then you learn how to integrate different things. There is no product rule to integration. There is no quotient rule. Okay, there's only U substitution rules and EU. So U meaning like if I'm integrating a U, that would be U squared over 2 plus C. What's that? No. Don't touch. Nothing. Okay? If I'm integrating like U squared, you would do what? You'd add 1 and divide. Okay? But if I'm integrating e to the U, what's that? EU. And if I'm integrating 1 over, whoops, that was supposed to be 1 over U. What's that? Okay, so these are the only rules we know. There's obviously some trig ones, but there's no rule for this one that we know of right now. Okay, so for example, if I tried to do it the power rule or the U substitution way, and I was like, okay, I'm going to make this my U, because usually it's the power. What's the derivative of z, or derivative of x? What's the derivative? 1, and then you put your dz here. And be like, okay, well then I'll call this du, and this one I'll call e to the u. And then I'll bring this 8 outside. You don't have to write this down. All right, no.
Do not touch.
Okay? And then some people will take the z and they'll call it like this. And they'll be like, oh, I can integrate u and I can go plus 1 and divide. You're not allowed to do it. It has to look like just that. Are you listening? Is this making sense? Or if it e to the u, I know how to integrate e to the u. Oh, no, it just can look like that. So there is no rule for this. So what we're going to learn today is another method. Okay, we learned separation of variables before. This is another method, and it's called integration by parts. Now, I'm going to let you know, at SPCC, they do not do integration by parts in Calc 1. But at NC State, they do integration by parts in Calc 1. At another school, though, they move integration by parts to Calc 2. So it depends on what school you go to. That's why if you're thinking about or even leaning toward being an engineer, I would take calculus at your specific school, especially Calc 1, because you never know where they're going to end Calc 1 and start Calc 2. So it's always good to do that. But here's the integration by parts method. And it's literally a formula that I want you to write at the top of your paper. This one I do want you to write. It's called the integration of UdV is equal to UV minus the integration of V du. This right there is the formula for integration by parts. Now, the first and hardest thing to do is pick your U. So just like anything, we always want to pick a U correctly. Well, there's an order to picking U. So to pick your U, in order, you use the following phrase, liate. And this will help those of you who kind of like liate. Yes, you want to pick this as your U. So L representing logs or logarithms or ln's. You want to let that be your U first, okay? I stands for inverses. You don't have to worry about that here because we didn't do inverses in brief calculus. We do inverses in Calc 1, but we won't do it in here. A stands for algebra. Now, when I say algebra, I mean something like 2x cubed. You would let that be your U. 2x cubed. Anything algebraic looking. Anybody want to take a guess what T stands for?
Terrible guess.
Trig. Last but not least, guess what E is? Exponentials. Okay? And exponentials being like e to the x. That would be the last thing that you would ever want to call your U. Okay? Now, we're going to work through these problems together. And I made it specifically so it looks like the quiz. So this is going to be similar to question 1 and similar to question 2. So you're welcome. Okay? So you need to follow along. The other thing I'm going to teach you, there are 2 ways of doing this. I'm doing it the old way because the old way never fails, but I am going to show you for these 2 right here something called a tabular method. And you can look it up if you want to. The tabular method works for these 2. It will not work for 3 or 4 or 5. It won't, and then I'll show you why in a moment. So, all right, y'all ready to rock and roll? So let's do this one. Give me one moment. I always want to write my formula at the top. So the integral of u dv is equal to uv minus the integral of v du. And always pick your u by Lie8. Okay, so when I'm looking at this integral, what do I want to let my u be? The 8z or the ez? Well, according to Lie8, a comes before e, correct? Okay, so I'm going to let this 8z be my u. Then the ez dz would be the dv. And now I'm integrating u dv. U dv. You with me? Yes. Okay. So once you know what your u is, you can now create this little rectangular box. Your u is 8z. Underneath it, you're going to write du. Y'all good? Do I need to stop? You can teach yourselves. Okay. Yeah, I know you do. Okay. I'm not hating. I'm just waiting. Thank you. Thank you.
Is Judah better yet? Is Judah better yet?
I'd like to get this lesson done. Okay, let's go. Okay. Picked my u, write it there. What do I put here for dv? Ez dz, because that's the, and I'm gonna, and now why are they doing dz? Because that's what they do it on the myopen math, so we're gonna keep it like that. All right, when you go from u to du, you take a derivative. But when you go from dv to v, you integrate. So that would be the backwards. All right, what is the derivative of 8z? 8, and then it would be dz because that dz comes over. What would be the integral of ez? These, again, are derivatives. Remember, I could have written them as, what you're not realizing, that you're not remembering, is we usually write it like this, over dz, and then we multiply by dz, multiply by dz. That's why that's coming over, okay? So this is your derivatives. Okay, now we're going to follow the formula up here. This part I already have, that's the original, correct? So I'm going to start at where the equal is. And I'm going to follow the formula. The formula says, take your u and multiply it with the v. U times v. So guess what I write? 8ze to the z. Then you write minus. Then you make an integral sign. And you integrate v times du. Well, in my chart, v is 8 is ez, correct? Du is 8 dz. Well, I like it with the number in front, so I'm going to write 8 ez dz. Okay? Now, once you write it like this, you're going to have to integrate again. So I'm going to cover this up. What do I do if I had this problem like a week ago? What would I do with that 8? I would pull the 8 outside. And what is the integral of e to the x, or in this case, e to the z? E to the z.
Uh-oh.
Help us, Lord.
That's 1 over.
And then what do I always add at the end? Plus c. This part right here, you're just going to drop it down. 8z e to the z. My friends, that is the answer. That is the answer. Okay? And that table is happy. Now, That is a no-fail method for doing integration by parts. You all need to stop right now. I'm telling you, I'm going to get annoyed. Stop turning around. Stop doing whatever you're doing. Stop the chit-chat. I can't deal with it. I want to get this done. I'm telling you, we have like 2 or 3 more left that are not going to be super easy, and you're going to be like, ah, 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 and it drives me insane. And my nerves are already shot. Okay, I'm going to show you what's called a table method, because honestly, this is not a bad method, but this method will make this question go much easier on the quiz. And the table method goes like this. You're going to draw 3 places, and you're going to write signs, D, and I. The signs will always be the following. Excuse me. If you notice, this term right here starts positive, and this second term starts negative. Do you see that? The sign will always go plus, minus, and it'll just keep going in that pattern. Plus, minus, etc. Your D stands for derivative. So you're going to put your U right here, which again, we said our U, according to Lie 8, was algebra. So we're going to put 8Z here. You're going to take a derivative until you get down to 0. So what's the derivative of 8Z? 8. And what's the derivative of 8?
0.
So you don't really need that little section right there. Okay? The I is the dv part, the integral part. And we don't have to write the dz. We're just going to write e to the z. But it's easy to integrate. Thank you. I'm here all year. What is the integral of ez? E to the z. What's the integral of e to the z? And you go as many times until you get down to that 0. Okay? Yeah. All right. If it's an E problem, yeah. Okay, now watch this. Here's how you write out your final answer, and we'll match it up with what we have here. Multiply the sign and the derivative together, and then multiply that with this one. So positive 8z times ez. Isn't that what I have right here?
It's a Christmas miracle.
Okay? Here's the next one. Watch. Negative 8 times z. Negative 8 times ez. That would be your next. Isn't that what I got here? And then, once you get to 0, there's nothing to do with 0. You just write plus c. So you're skipping this integration right here, essentially. This tabular method, like I said, is great when you have e's and algebra. It does not work when you have LNs, and I'll show you why in a minute. But we'll do it on the next one. But it's going to work out really nice for the first 2. Yes, darling?
Why did you not do the top one?
Because that sets us up. You always skip that one.
Oh, okay.
Yeah, you always skip that one and then skip this last one here. Yeah. All right, let's do it again. Next one. Set this up. We're going to do it the old way. You have to do it both ways because it'll just help you in the future. All right, according to Lie 8, what would be my u? 2x. So I'm going to let this be 2x. I'll take a derivative in a moment. That means the e to the 6x is my dv. E to the 6x. Are you with me so far?
Yes.
Okay. This part is going to be easy. You're all going to remember this. What's the derivative of 2x? 2 dx. This part is where people are going to forget because they haven't done it in a while. Listen to what I'm saying. Okay? I have to use my different color pen. What is the integral of e to the 6x?
E to the 6x. LN.
We're not talking about derivatives. It's not chain. Okay.
Over 6x.
Oh, 6x over 1.
Gare Bear, you might be on the right track. Hold up. Shh. Stop and watch. Listen. If I had given this to you on the last test, which I did, okay, you called this u, did you not?
Yeah.
And then we took a derivative, which was 6. Are we allowed to have a 6 over there when we integrate? Oh, we divide it out. And so it's 1/6 the integral of e to the u. So the integral of this is 1/6 e to the 6x. Okay? This is going to be hard for some of you because you're like have to go back to what you did last week, and many people forgot.
I don't even remember what I had for breakfast.
Exactly. All right. So let's go follow the formula. V minus the integral of v du. Okay? So u times v. What is 2x times 1/6 e to the x? Well, what's 2 times 1/6? 1/3 x e to the 6x. That's this part right there. I just multiplied u times v. U times v. Minus, integrate. Now write v du. So write this way. V du. What's 1/6 times 2? 1 what? 1/3 e to the 6x dx. All I did was write it out, correct? Okay. This part you have nothing to do with. It's done. But this part you have to integrate again. We need to move the 1/3 out. And we're going to be integrating e to the 6x again. But don't I already have the integral of e to the 6x right here? So what do I do with that 1/6? Oh, I just pull it outside, right? Don't I just move that 1/6 to the outside? So it's 1/3 is already out there. 1/6 becomes out there. The integral of 6x is just e to the 6x. And what would be in front of it? And then bring that minus down here, and then bring this, and that is the final answer. Oh, plus C, thank you. Brilliant. Yeah, plus, oh, the blocks did say plus C, that's why I didn't write it. Thank you. No, you do not keep the DX, Sharon. What in the world? Thank you, Taylor. You're a good girl. You're so good. That's Why is everything gotta be that way?
Act like you're stuck on the scale all the time.
JD. Okay, let's do it the sines derivative integral way. Plus, minus, plus, you just write them as much as you can. Keep the same u. The u was what? 2x. What's the derivative of 2x? 2. What's the derivative of 2? Once you get to 0, you're good. Just stop. And now, here you would put e to the 6x. Okay, and we already integrated e to the 6x. What was it?
1/6.
Then what would the next one be? No, you're 1/36. You're skipping to try to look at the thing. It's 1/36 e to the 6x. What would the next one be? Will it be 1 to the 2/16 or something like that? We don't have to do that. All right, now watch, just to make sure. Multiply these two together, and then multiply it with this one. Doesn't 2 times 1/6 make 1/3? And then the x, and then I have the e to the 6x, so it matches. All right, let's see if this one's going to work out to be 1/18. Negative 2 times 1/36 is negative 1/18. And then you put your plus c. So on homework tonight, those two are going to be just that easy. Very easy. All right, I'm going to tell you right now, this one is the hardest one of the lesson. The other two are actually easier than this one, so you got to pay attention. Lock in. You cannot do this as, unfortunately, a tabular method, because there is no way to integrate ln, and there's no way to make this nice. So we're going to have to do it the old way. No. All right. Your u is going to be the ln of 9t plus 5. It's the entire thing. Because remember, Lie8 says pick log first. So ln of 9t plus 5. Okay? We got to go over derivative rules. How do I take the derivative of an ln of something? What do I write? 1 over times the chain. Because with derivatives, we times the chain. Remember, if I said, what's the derivative of the ln of this? You'd say, oh, it's 1 over that times this chain. So my derivative would be 9 over 9t plus 5 dt. Are y'all with me? Okay. The dv is just dt. Or you could call it 1 dt if you want to, because that'll help you out. Or like 1 dx. Integrate 1 for me. What would be the integral of 1? What's the integral of a number? If I had a 5 here. No, what is the integral? 1x. The integral of 5 is 5x. You got to work both ways. I know, this is hard. Yeah, it's hard. Okay. Now, let's follow the formula. You go ahead and write it out. uv minus integral of v du. When you write u times v, by the way, always put the v, like, I don't know why couldn't they write vu, but you should put your t in front. You shouldn't put it in the back of an ln. You should put it t times the ln of 9t plus 5. That's this part right here. Do you agree? Yeah. I just put the t in front. I don't like the t on the back. Minus the integral of, what would I write here? What, integral of what? T times this, yes? Okay, well, another way to write that would be 9t over 9t plus 5.
You don't do it top and bottom?
No, it's t over 1. It's like t over 1. Okay, I'm going to let you know you're not going to love this. It's going to be like this on the quiz. You do know how to do this. You haven't done it in a while. Do you hear my tone right now? Shut up and listen. And I'm not deleting this from my quiz, my video. Okay, shut up, calm down, you know how to do it. I'm going to write this on the side. You do not know how to, there is no quotient rule for integrating. There's no quotient rule. You have to make this look like u's and du's. This is your u usually, but the derivative of that is just 9, not a 9t. So what you have to do, and I did this as an example, you can look back in your notes, you have to divide this. You have to divide that into that. Trust, don't question, just do. 9t plus 5, the bottom into the top. 9t plus 5, how many times does 9t go into 9t? 1 time. Multiply, subtract, you would end up with negative 5. That negative 5 would now go over what? 9t plus 5. What you just did, listen, is you are rewriting this as the integral of 1, which is easy to integrate, minus 5, 9t plus 5. It seems illogical. It seems like, why should I integrate now 2? Because it's easier to integrate 2 of them than it is to integrate this one right here. Okay? Now you ready? Now for the next part. Integrating 1, super easy. What's the integral of 1? Any number again.
1x.
1x, or in this case it's t. So that's easy. Okay? This one right here, watch. I'm going to put this on the side. This is actually, I'm going to put it, well, you're going to put it here. I'm going to put it on here on a larger scale. If I integrated 5 over 9t plus 5, by the way, this was on your last test. You called this u, did you not? And if we took a derivative of that, we would do what? We would get 9dt, and what did we do with that 9? We divided it out, and we had 1/9 du, did we not? Okay? And so what I ended up happening, listen, that 5, could I not bring that over also? So I had 5 on the outside, I have 1/9 on the outside, and I have what? 1 over u. Well, how do you integrate a 1 over u? So again, this right here becomes, watch, 5/9. So we'll put a minus 5/9. The ln, what's my u? 9t plus 5 plus c. That's why we have to separate it into 2 different parts. Okay? Now watch what's happening. There was a minus sign in front of the integral. So you are going to have to distribute. I can't remember if they are going to allow you to write it like this. But if they don't, just distribute. It would be minus t and then plus 5/9. They let you? Okay.
Oh, I have a question. So,
Yeah.
I kind of already did this one.
Yeah.
But, so basically, every time I did it, the second number just went on top of the first number. Like how I did it.
Yeah. The second, what do you mean the second number? The 5 here?
Yeah, like,
Oh,
it always went on top of it.
really? Oh, they must have, that's an algorithm
Every
then.
single problem
Yeah.
is like that. It's like
This is a hard one because, no, you do not distribute the C. The C is just always a plus C. Yeah. I like it because it kind of goes back to what we're doing, but I'll tell you, it's hard. This is very difficult for some people. All right. Yes, darling.
You don't have to add another C at the end.
No, because when you're adding all your C's, what essentially happens is they just become a C, a constant. So, all right, flip it over. You're going to love this one. No, you are. Do you all have a calculator? Does it have Math 9 on it? Do you know why this one's going to be fun for you? Literally plug it into Math 9. And you only have to write the answer that it gives you, which is not 27.45. If you want to check me, you can, but that's all you have to do. When they have this is called a definite integral because it's defined by 1 and e. You don't have to work it all out. You're welcome. Plug it in the calculator. Let the calculator do the rest. Done. Done. All right. And with that said, let's move to our last problem. All right. Here we go. Set up the table for me. What's my u? 27.45. ln x because it follows the lie 8.
How often, like, can we just math 9? And how do we know?
Only when it has a definite integral. Only when it has the two parts, a and b, the part of it, yeah. All right, so if this is my u, that part right here must be the dv. Would you agree? All right, and I don't want to leave it as the square root of x cubed. I want to write it as x to the what power? 3/2. So we're going to write this as x to the 3/2 dx. Okay, you do these two right now. What's your du, what's your v? Derive one way, integrate the next. This is why Calculus 2 to me is a weed out class, because you have to know both struggles. You can do it. One over x dx, right? What about the other way? Add 1 and divide. 2/5 x to the 5/2. Good job, yes. Okay, now, we got that far. Write your formula out. This is the same formula, uv minus the integral of v du. Okay, you're going to multiply these two together. Again, don't ever write ln of x and then that next to it. Usually put your algebra in front of the ln. So this is just 2/5 x to the 5/2 ln of x. That's what that right there is. Minus the integral of v times du. Now watch, there's a little cleaning up to do. 2/5 x to the 5/2 times 1 over x dx. Did you all see that, right? But isn't 1 over x the same as saying x to a -1? And don't I have two like powers here that I'm multiplying, which means what can I do to the exponents? I can add them, which was just subtraction, yeah. So this is really the integral of 2/5 x to the, is that 3/2? Mm-hmm. And yes, you have to integrate again. And you're going to pull out the 2/5. But honestly, aren't I integrating what I just did up here? It always works out that way with integration by parts, by the way. So it's going to become another 2/5 x to the 5/2. Well, I should say. It's not integrating anymore because I'm writing it correctly. Sorry about that. Okay. I know. I'm sorry. Nothing. No, I know. I'm confusing you. All right, stop. All right, integrate this for me. You would have add 1 would be what? 5/2. So you'd be multiplying that by 2/5 again, right? Which is what? 2/5 times 2/5 is 4/25 x to the what power? 5/2. Put the minus. put the plus C, and then what else do I need to add?
Two things that we did.
That thing in front. And that is the answer. Sorry, I was trying to skip in my head and show you what my head was thinking like, but it didn't. All right. So the hardest one is question 3. The other ones are pretty easy. Now, homework tonight, you can choose to do quiz 3.5. Or you can just wait till Sunday, which might be good or might be bad for you. I don't know. Or you can at least get a start on it. Get a start on it. That way it's not hard. Is it easy? Did you do it? Is it only 5? Is it only 5 questions? 7. I think I added 2, yeah. Just want to see if people...
So, wait, I'll just.
Okay.
So, this is like really good. So for